Hi, this video is to help you with IXL CC 21. So in this lesson, we have to find the probability using the normal distribution. A normal distribution is a distribution, when you graph it, is when you get the shape of a bell. It's like a symmetric bell. Okay, so remember that. That's all normal distribution means. Okay, it's like a symmetric bell like that. Now there are three cases of how do you find the probabilities. Alright, remember that the mean is given by the symbol x with the bar on top. It's called x bar, it's called the mean. And standard deviation, that's the symbol for standard deviation. Standard deviation. Now, I'm going to give you a simple example. Let's say the mean is 50, okay, and the standard deviation is 5. Let me show you what this means, okay, with respect to these graphs. The mean is right in the center, so all it means is in the middle you have 50. So in all these three cases, I'm going to put that the mean is right in the middle, 50, okay. The standard deviation means a change from a number. So from the mean, how much does the values in this data deviate? That's what it means by standard deviation. So if I take 5 and if I do minus 5, I get this number, plus 5, I get the number here, right? So if I get minus 5, I get a 45. If I get plus 5, I get a number 55. So what do we know about? So here what we did is, this is your x bar, this is your mean. This is your mean minus 1 times, or mean plus 1 times standard deviation. So I added and subtracted the standard deviation once on both sides of the mean. So what it means in terms of probability is that all the data between these two numbers, between 1 times standard deviation, the probability will be 0.68 always. Okay? No matter what mean I pick and what standard deviation I pick, if I subtract the standard deviation 1 times and add the standard deviation 1 times, if it's only 1 time that I'm adding and subtracting standard deviation on both sides, the probability of the data in that area is 68. Okay? So, in 1 half you will have, this whole thing is 0.68. So in 1 half you will have 0.68 divided by 2, which is 0.34. So that will also be 0.34. So 0.34 plus 0.34, you will get 0.68 as your probability. Okay. So whenever these numbers are a multiple of 1 times standard deviation on either side, the probability is 0.68. And if they only ask you for 1 half's probability, it's half of it, 0.34. Now in case 2, let's say the mean is 50 and the standard deviation is 5, but I am subtracting the standard deviation twice. So minus 5 and another minus 5. So this is my x bar. So from x bar, I subtracted the standard deviation twice. So this number becomes what? 40. So plus standard deviation 5, 55, plus another 5, 60. So this is x bar plus 2 standard deviations. So I get 60. So how much of this data in this figure is between 2 times the standard deviations? So from here to here, the total data, there's more numbers between, but this is a larger range than the first case. So there are more numbers here, so the probability here will be higher. It's 0.95 of the total data lies between within 2 times standard deviations from the mean. That's what it means. So this entire part from here all the way up to this point here is 0.95. So if you look at only 1 half of it, it will be half of that number, which is 0.475. You just divide this by 2 to get that number. 475. This is for the half. This is for the full curve. Okay. Likewise, this is for the full curve. This is for the half curve in this case. Now in the last case, We know our standard deviation is 50. I'm going to go 3 times on either side. Let's see what's going to happen if that happens. One standard deviation, second standard deviation, and the third. So that's x bar minus 3 times standard deviation. That's my x bar. 1, 2, 3, the third. That's x bar plus 3 standard deviation. Now what's going to happen if I have more data, right? There's more numbers involved in this range from here to here. So the probability will definitely be greater. And it's given to be, we don't have to find what the probability is. It's the formula. It's given, always given to be 0.997. So 99% of the entire data is between these two numbers, between 3 times standard deviations from the mean. It will lie. So this is for the full curve from here all the way to that side. So if it was for half the curve, you would have to divide this number by 2, where you will get 0.4985 for the half curve. So after you understand this, we'll go and do the problems now. Number 1, x is a normally distributed random variable with mean 67. So let's roughly draw our graph, and we know that the mean is 67 and the standard deviation is 8. What is the probability that x is between 59 and 75? So 59 is somewhere here less than 67, and we know that 75 is somewhere here greater than 67. All you have to do is take your calculator, put your mean in the calculator and see how many times do you have to subtract standard deviation to get either one of these, subtract or add. So from 67, if I do minus 8 one time, what do I get if I do 67 minus 8? We get 59, right? So I had to subtract, this is x bar, and my 59 is x bar minus 1 standard deviation only. What about 75? I'm sorry, how do I get 75 from 67? I have to, since it's to the right, I have to add, how many times did I have to add the standard deviation? 67 plus 8 will give us 75. So I had to add, from x bar, I had to add the standard deviation once. And we know the formula for once, the probability is 0.68. So our answer will be 0.68. So I need this entire region plus this entire region. That's 0.34, and that's also 0.34. Together we get 0.68. Next question. X is a normally, whenever you see normal, you draw the bell curve. Mean is 40, so you put 40 right in the middle. And we know that the standard deviation is given to be 17, so we're going to put standard deviation is equal to 17. So from 40, we have to find what is the probability that x is between 6 and 74. So 6 is less than 40, so I put it on the left. 74 is greater than 40, so I put it on the right. So what you have to do is take your calculator, put 40, and keep subtracting the standard deviation to get, since it's on the left. One time when I subtract 40 minus 17, I get 23. I did not reach 6. So I keep subtracting the standard deviation again. Take away 17 again, I get 6. So this is x bar minus 2 times standard deviation. And let's see what's 74. So 40 to the right, so you keep adding. 740 plus 17, you get 57. And 57 plus 17, you get 74. So here I had to add twice. See? So when it's 2 times a multiple, we know the formula says that if it's 2 times, it's 0.95. So your answer is just 0.95. So some of these questions are really easy. All you have to do is how many multiples it is. How many multiples from the standard deviation are the numbers that you have. If it's 1 multiple, it's 0.68. If it's 2 multiple like this one, it's 0.95. And let's see another case here. X is a normally distributed random variable with mean 50 and standard deviation 16, so this is 50. What's the probability x is between 2 and 98? So from 50, keep subtracting the standard deviations. So 50 minus 1 times 16 or 2 times 16 or 3 times 16. How many multiples of the standard deviation? How far away is 2? So I'm going to keep subtracting 16 till I get the number 2. So when I multiplied it 1 times, I got 34. Keep subtracting 16. I got 18. Keep subtracting 16. I got 2. So I got my number over here, so that we know it's x bar minus 3 standard deviations. And if you check the other side, you will find out that you have to add 16 3 times to get 98. So that's x bar plus 3 standard deviations. So that answer automatically has to be 997. Okay, that's what the formula says. Now, this is a different case where you have to be careful. X is a normally random variable, so we draw a curve. We get the mean as 17, and then the standard deviation is given to be 25. What is the probability that x is between 67 and 92? Now in this case, 67 is on the right and so is 92. Both numbers are on the right. So we need the probability between these two numbers. Okay, so in this case we're only going to look at the half curve. So this is the one part of the half curve. We just need the probability till here. We just need to subtract these two numbers. This subtracted this will give us this answer. This is going to be our answer. Okay, so all we have to know is 92 is how far away from the mean. How many standard deviations away from the mean? So 17 plus how many 25s gives you 92? 17 plus 1 time 25 is 42. Add another 25, you get 67. So we know that 67 is 17 plus 2 times the standard deviation. And 92, you keep on adding another 25, you get 92. So 3 times standard deviation is this 92. So up to 92, it's 3 times the standard deviation. We know if the number is 3 times standard deviation, the probability is 997. But since we're only talking about this half of the curve, we have to divide it by 2 minus, since 67 is twice the standard deviation away from the mean, we have to take the number for twice, which is 0.95, and since it's just half the curve, we divide it by 2. So we get our decimals as 0.4985 minus 0.475. Answer is 0.0235, but we have to round to the nearest thousands, so we only need 3 digits. So when we round it, we get 0.024, since this number is greater than 5. So if both the numbers are to the right, or if both of them are to the left, you will have to do something like this to solve it. So try to do these problems by yourself. Good luck.